Hi, you have a website or a software or any piece of code that you wrote. It works perfectly fine on your own computer. In fact, it looks amazing. But your sister, she wants to see it. So, well, you compose an email, you attach your code, and you put in a few instructions on how to run it, and you hit the send button. Except she never got back to you. So you call her up and you ask her, hey, did you find it okay? You're expecting some praise, right? So she tells you that everything was okay until the second to last step, when her computer showed a pop up screen which said, please update before installing. And she never got around doing it. So you harass her, and then she finally gets it up and running. Yes! Except she cannot load that cool animation which starts at the beginning of the app. And you want the entire world to see this application. You need to make it run on AWS and things like that. How will you? It is so frustrating, right? Has this ever happened to you? I'm Ritika. I'm a software engineer at Apple. I have traveled across the world, worked in a few different companies trying to learn how to write and maintain good code. Currently, I work with the iCloud content delivery services team. So you can imagine that any code that I write has to run not only on my computer or on my manager's computer, but also the servers where people like you use my services every day. So, yeah, before we try and find a solution to our problem, let's take a short history lesson. The Romans, they imported black pepper from Indians thousands of years ago. A farmer in Kerala would pack them into bags, put them on a cart, and these carts would go to the ports. And on ports, there would be warehouses where they would be stored until a ship arrived. The workers, they loaded these bags onto the ship and then traveled across oceans and repeated the same transportation process. Cut to today, we use the same method to transport cars, oil barrels, and even coffee. And each of these items is very different. It requires its own attention. So, a trucker, he was really frustrated with the irregularities between his shipments, and he said, come on, there has to be a better way. And thus, the shipping containers were born. These big blue boxes, which will be a standardized unit across the world, and transporters don't have to care about what is in them. Today we have analytics softwares, big data processing software, applications that you and I make, simple websites even. They all have different needs, but at the end, they are all going to be run on some sort of a computer. So someone came up with the idea of containers for code. They were Docker. This is containerization, a standardization of putting your software into a code box which everybody understands. So let's look at this in detail. Your computer, you have a physical hardware. So, literally like your computer's CPU, the RAM, the fan on your motherboard, etc. These things do not work without their software on it. So the basic principle is that you first run an operating system. This could be your Mac OS, it could be Android, Windows, etc. And then you run applications on top of it. So you could have websites which run on applications like Safari. You could have native applications like Notes or Chess, games. So what's next? Now, deployment is the process of making the software available to everybody. So let's say I'm creating this website and I have written all the code, but obviously you don't care about it. You don't have access to my code, and you just want the website. You want to see the website running. And the process of making this code into website and making it available for you to see, this is called deployment. Now, in your traditional computer, the one with hardware, operating system, applications, if you wanted to deploy an application on this architecture, it would be slow because first you'd need the hardware, right? So you'd go and purchase a laptop. Then you need to install an operating system which would have to run perfectly fine. And then you would launch your application on top of it. Now, to add to all of this, your hardware, let's say your RAM, the CPU cycles, they are not 100% used by your application alone. So, what happens to the remaining system resources? Nobody's using them, so they go to a complete waste. Another problem with these traditional laptops or computers is that it is very difficult to scale as your app grows from one user to a million users. So let's say just one single computer is serving 100 users. You would need 10 such computers to get to 1,000 users. Can you imagine getting to your first million users using this approach? It is extremely a slow process. You would have to run the operating system first on each one of them, then deploy your application on each one of them, and then take care of 10 different physical and virtual computers. So you would have to literally do the same process 10 different times. So as you can see, scaling up with this is not at all easy. So to solve this myriad problem, someone came up with the idea of virtual machines. So let's see what virtual machines are. These are like a traditional computer. You have a physical hardware, and then you have the operating system. So far it looks pretty traditional. Then instead of launching your app directly on the operating system, these guys, they created their own application which was called the hypervisor. And this is like an abstraction. So it sits between your operating system and the application. So an application which is running on top of the hypervisor, it doesn't know what it is running on. So you could spin up multiple of these virtual machines and have multiple applications running on the hypervisor. Now, inside each of these virtual machines, you are able to launch different operating systems. And finally, you are able to separate the file system. Thus, you're able to guarantee that there is privacy between your applications. So, for example, your Notes app and your Chess app don't have to access the same files. Each virtual machine, in fact, thinks that it is its own computer, but actually, in reality, they are sharing the same physical hardware. So the hypervisor does this tricky job of maintaining the different compartments, but for applications, it doesn't even matter. Now, this is a great thing for you, the developer, because let's say you write 2 different apps and you don't want to buy 2 different laptops to run your 2 different apps. So you will just buy one computer, one physical hardware, and you will run 2 virtual machines, and you would launch them in different virtual machines. You have 2 different applications. Now, you get isolated file systems because each of these virtual machines is thinking, hey, I have my own file system, right? I have my own network, I have my own memory space, etc. It is super easy to scale. And today, we are able to launch these virtual machines in cloud. So AWS, Google Cloud, Azure, whatever it is, everybody offers virtual machines. So you could literally launch 2 different applications on the same physical hardware, which, by the way, is not even your own hardware to begin with. Now, however, each of these virtual machines still need their own operating system, which means they need a dedicated CPU, a dedicated RAM, dedicated memory, etc. So all these physical resources still have to be real. And if you're like me, you're thinking, hey, I just wanted to launch one app. Why did we create like a whole different operating system to do it? Like, why did we have the guest operating system in the first place? We should have probably skipped it, right? And plus, the additional issue of buying more hardware still exists, because if you want to launch more VMs, virtual machines, you would still want to have like more physical resources. So if you look at this slide, it pretty much does the same thing. You look at the green boxes. They look pretty identical to the virtual machine boxes we saw earlier, except these are called containers. And the only missing part in this entire system is the guest operating system. So the physical hardware already has an operating system. And so the Docker folks said, you know what, let's try to use this as the hypervisor. And they made the Docker engine. This allows you to deploy apps on any hardware you like without having to install an operating system on top of it. So you still get all the good things. You have the isolated files, you have the isolated network. You just have to, just like the virtual machines, you would have containers in the cloud. It is easy to scale because you can just spin up new containers, and instead of spinning up new virtual machines, which also required you to launch new operating systems, it now allows you to save resources. It allows us to save time. Launching new virtual machine, in fact, can take up to tens of minutes. I've done that before. But launching containers, it's just a matter of a few seconds. Now, remember our traditional computer, like the ones we have, where we launched multiple apps and we did not utilize all the extra system resources. So now you can be like, you know what? I have some extra memory, I have some extra space. Why don't I launch my second application right here in here? So you can have multiple containers and you can have multiple applications in each one of these multiple containers. Now, the original reason why we started all of this was because my sister was not able to simply run my code that I gave her on my email. Because she needed to upgrade some library that she didn't even know about. So if I make a website, let's say, which uses Java, I need to make sure that my sister's computer has Java to run it. And thus Java becomes a dependency of this website, of my code. Now, Docker, it will ensure to install this dependency no matter what kind of computer she's using. So my sister does not have to install Java or wait for a couple of hours, restart her computer, update her PC, etc. None of that. So as you can tell, it's pretty portable. My code on my computer to my sister's computer, same thing. You're also able to share resources, by the way. So, and that only when you want to share resources. So let's say you launched a container 1 and a container 2, and you decide, you know what, I actually want that my Notes app and my Chess app, they should have access to the same file system. Let's say I want to be able to share images between them. And I trust that these two applications can run in the same container. So they can even share the same libraries, and I don't have to like copy and paste or reinstall the same libraries on different containers all over again. So I can install two applications on the same container. Now, none of this is dictated by the operating system or what kind of an app you are making or what kind of a framework you're using. It's just the flexibility which allows you to decide how you want this whole thing to be deployed. Now, another great feature about Docker is that it is super easy to scale. All you have to do is spin up containers that you already have. Let's move on to collaboration and how this brings us more power. So the great things about virtual machines and containers is that you can use them together, and it does not have to be a question of should I use a VM or should I use a container. You can just use both. I'll give you a very good example of why you might want to do this. So let's say this is my computer, and because I'm a developer, I like writing multiple kinds of applications. I wrote a big data software, I created a website, and let's say I created another desktop game. Now, I know my physical hardware, like I have a computer, right? And let's say I'm using Mac OS right now. So Mac OS becomes my operating system. And now I decide to run Docker on it. And then I launch these three different applications, my big data software, my website, and my game in three different containers. So this makes sense, right? As a developer, my job becomes super easy because these three things are isolated and they're not connected to each other, and I can run and test them using my same machine. Now, after months of development, I have decided that my applications are now ready to be introduced to the world. I want everybody to use my game. I want them to play it. I want everybody to visit my website. And at the same time, I want everybody to be using my big data processing software. So I go to a production server company and ask them to launch my applications. So they give me a hybrid container and VM bundle. Now, they launch a hypervisor on their physical hardware, and my, let's say, app, my game, and my website, they share the same operating system. However, let's say my big data application runs on a different virtual machine because it's clunky. So, meanwhile, this production server company has more resources left on the physical hardware. Not that many people visit my website, right? So, you know what they do? They rent it out to another developer. So we're both now sharing the same physical resources and we both save some money. So happy developers, and more importantly, very happy administrators. Applications can be speedily deployed. There's a very high degree of portability since we do not depend on one particular operating system, and we are efficient. Like, there are no physical resources like RAM, CPU cycles, which go wasted. So if you want to make your life easier, I would highly recommend that you check out docker.com. A starter tutorial would take you less than 15 minutes, including the setup. You can start extremely small. You can do a simple demo application first. In fact, I have done this before, and porting your app to Docker requires you to barely add like one or two extra files. And that's it, your existing configuration plus a file or two extra. This will go a long way for you to collaborate with your co-developers. Additionally, please reach out to me. My Twitter is at Nevatia Ritika, or there are more ways to contact me via my website, nevatiaritika.com. Thank you so much for being here. Looking forward to connecting with you all.